GM, welcome to my talk, Getting Started on Morph. This is a complete developer's guide to understanding what Morph is and how to get started building on it today. Hey, my name is Rahat. I'm Senior Developer Relations Engineer at Morph. You can find me usually any place at Rahat Codes, Twitter, Telegram, wherever. Pretty accessible. If you ever want to talk about anything you're building during this hackathon or beyond, I'm always up for that. So a little bit of an agenda of what we're going to go through today. First, I'll give you an introduction to what Morph is, an overview of the architecture. We'll go through setting up your wallet, going through the bridge, deploying and verifying a contract with Foundry, as well as using VM on the front end, and putting that all together so that you have everything you need to start building. I'll also be providing you with additional resources that you can use to help you during your hackathon experience. So what is Morph exactly? So Morph is an Ethereum layer 2 scaling solution harnessing the power of an optimistic ZK EVM. We're going to go into what that is during the architecture side of things. But there's three things that we really prioritize, and that's one, consumer-centric innovation. We're building a blockchain for consumers, transparency and trust, and collaborative ecosystem. Now, on the technical side, what is Morph? Morph is made up of three main modules. First, the decentralized sequencer network, the optimistic ZK EVM, and the rollup contract and bridge. Let's go through each of these things. First, it's going to be the sequencer network. Sequencers are responsible for creating your transactions and putting them into blocks. So, in the case of Morph, what we have is a sequencer network. So rather than having just one sequencer, going through each of the blocks and creating these transactions, we have a set. We have a staking contract that exists on L1 or Ethereum that governs which sequencer is going to be creating this current block. So the sequencer gets chosen through the selection process and then starts to create the block. Tendermint is what we use for a consensus between the sequencers. Now, when these sequencers actually create each of these blocks, rather than sending each and every one through the rollup contract, which is the second module, it actually sends them in a different batches. So we have different checkpoints where the sequencers will use what's called a BLS signature in order to verify the blocks and send them over to the rollup in aggregated bunches. Now, the third part of all of this is the optimistic ZK EVM. So the optimistic ZK EVM is built on what we call a responsive validity proof. Now, generally, you would have two types of proofs in L2s. You have your fraud proofs and you have your validity proofs. We took an approach that kind of combines a little bit of both sides. So what are these different types of proofs, right? First, let's take a look at the interactive fraud proofs. So fraud proofs are what are generally used by optimistic rollups. So we assume, all the transactions optimistically are fine, non-fraudulent. But in the case that there might be some fraudulent activity, a validator can come in and initiate a challenge against a state verification contract to prove or disprove the validity of a specific transaction. Now, when this happens, the challenge goes through a back and forth process between the validator and the state verification process. This process can be very lengthy, and this is what usually results in what you would see with these 7-day withdrawal periods and 7 days needed for finality. So on the other side, you have your ZK validity proofs, generally used by ZK EVMs. Now, rather than having these challenges, what ZK EVMs do is that for every single block, a ZK proof is generated to prove the validity of that block of all the transactions in it. Now, this, you can probably see this as being more secure than using a fraud proof, but generating a ZK proof for every single block is going to be very costly. Now, we decided to look at these two approaches and create the responsive validity proof. So in this case, we still have sort of like this optimistic outlook that all of the transactions will be fine. However, again, a validator can initiate a challenge with a state verification contract. But in our case, rather than this back and forth process, our sequencer will actually request a ZK proof to be generated from our prover to actually validate the state. This reduces the finality and wait time from 7 days down to 1 to 3 days. And additionally, when we look at these different types of proofs and the way that our architecture is set up, we can actually switch over to a full-on ZK VM in the future once the ZK tech has matured just a little bit further. Now, how exactly does this contract, this challenge actually work? So a validator is going to be viewing all the different transactions that sequencers are creating. And if a validator says, okay, there is an issue here, first of all, in order to become a validator, you need to stake a certain amount of ETH. Same thing for a sequencer. These are slashed depending on your behavior. In the case of a validator, if it initiates a challenge and it is incorrect regarding that challenge, those funds will be slashed. In the case of the sequencer, if a challenge is initiated and it cannot prove that the transaction is what it should be, its funds get slashed. So there's incentives on both sides to make sure there's no malicious behavior. So like we said before, a validator will actually go ahead and initiate the challenge. Once it initiates the challenge, the sequencer will request a ZK proof, and our ZK prover will create that and will send it to the challenge contract for verification. Challenge contract exists on L1, and the sequencer and the process for that exists on L2. So let's go ahead and start looking at our testnet, get our wallet set up, take a look at our bridge and our explorer before we head into a little bit of code, both on the smart contract side and the front end. Let's get started by taking a look at how we would set up our wallet. If you head over to docs.morphl2.io and head over to our quick start, you can go over to wallet setup and you'll see here that you have everything you need to add the Morph testnet over to your wallet. A quick and easy way to do this without doing it manually is head over to Chainlist and you'll be able to add Morph testnet over to your wallet right away. Now let's take a look at faucets. In order to get some test funds to use on Morph, you'll first need to get some Sepolia ETH. You can use any of these faucets to do so. After you've done that, you'll need to go over to our bridge. These instructions will walk you through how to bridge some of your Sepolia ETH over to Morph. Once you've bridged that over, you can go ahead and start exploring our explorer. Now that we've gotten to this point, let's go ahead and start writing our first smart contract. We're going to be using Foundry to do so. Going into my terminal, and I'm going to create a folder called counter. Let's go into our counter folder and run forge init. You'll need to make sure that you actually have forge installed. If you need to do so, you can go to book.getfoundry.sh and go through their installation steps over here. I've already done that, so I'm going to go ahead and continue here. I'm going to go ahead and open this in my text editor of choice, which will be VS Code. And if we go into the counter smart contract on the source folder, we'll see that we get a nice little basic counter smart contract out of the box. Let's add a couple more functions to this. Although a public variable will automatically give us a nice getter function, well, let's write one ourselves. Let's see what that looks like. So we'll call this function getNumber. This will be a public view, and we'll return a unsigned integer. And it's simply going to return us this number up here. We're also going to do another function called reset counter, just in case we ever want to set this down to 0 again. Now, normally for a function like this, you'd probably want to guard it and make it so that only an owner or an admin can actually reset something like this. We're going to keep this pretty basic, but you can look at different standards like OpenZeppelin, who've got a library of smart contracts that'll help you add this type of functionality. I'm going to save that. Now let's get started on actually deploying our first contract. For deploying this contract, we're actually going to use a script. Let's go to the script folder and look at the current one. So this is the one that comes out of the box. Let's get rid of this. And we want to also import our contract itself. So we're going to import counter. And in here, and let's just rewrite this function real quick. We'll still call it run. It'll be an external function that returns our counter. We're going to use this vm.startBroadcast, which will give us some nice logs if we need it. And let's go ahead and deploy our new counter. We'll just call it lowercase counter. Then we'll use vm.stopBroadcast. And you'll see how this works in just a second. And finally, we will return our counter. And let's not forget semicolons. So this is our script for deploying our contract. Before we go ahead and deploy, let's go ahead and create a .env file. In the .env file are going to be 3 variables. Our private key for deploying this, an RPC URL, which is just going to be this public one, and the verifier URL, which is going to be what we use to actually verify the smart contract. Let's go ahead and save that. Make sure you update this to be the value that you need it to be. Now that we've created the .env file, we need to actually use it. We'll use this command source.env, which will allow us access to all the variables inside of the .env file. And now I'm going to copy over a script that I have, which is going to be available in our README as well. But this is a script to actually deploy our smart contract using the script that we wrote and using the variables within our env file. One important thing to note is to make sure that you pass this -- legacy flag whenever you're deploying to the Morph testnet. Hit enter. Everything will compile. Great. We'll see the total amount that we paid in gas to actually execute this contract, and we have the contract address up here. So let's copy that and head back over to our browser. Look that up, and you should see that the contract, which I just created, was created about 44 seconds ago, and this is the contract creation type there. Now we've got our contract deployed. Let's go ahead and create our front end. We're going to use Next.js to do this. So we'll use yarn create next app to scaffold out our app. We're going to go ahead and call it front end. Say TypeScript, yes, lint, and we're going to use the page router. Now, a thing to remember is that the finalized version of these are in separate folders in our Morph examples GitHub repo. So you'll have both a front end folder as well as a smart contract folder, which will go through not only the Foundry example, but also doing a hard hat example if you'd prefer hard hat. But now that we've got the front end here, we're going to go ahead and navigate into there and open that up in a separate code editor. In our source folder, I'm just going to go ahead and create an abi.json file. And just to make sure we have our ABI, let's head back to our counter. Once we're in our counter, we're going to use this command, forge inspect counter ABI. This will give us the ABI for our contract. Let's go ahead and copy that over. Into our abi.json. Now we have everything we need to connect to our contract. Let's get started on installing a couple of items. Head back into our front end folder. we're going to be installing a couple dependencies. First, WAGMI, VM, and finally the TanStack React query, which is all things that we need to make sure that WAGMI React hooks work properly within our project. So let's install that. Once installed, let's head back to our front-end code base. And we're going to, in our source folder, create a file called wagmiconfig.ts. Set up the configuration file for our WAGMI config. You can copy all of this mostly from the documentation available from WAGMI, but this will let us create the connection to the Morph network. Save that. Now in our _app.tsx, we're going to update a couple of items here. Now a lot of this is just boilerplate code, so I'm just copy and pasting everything from the Morph examples GitHub repo, which you should also have access to. But all we're doing here is taking our WAGMI provider, making sure it wraps our entire client, as well as the query client provider from TanStack Query to make sure that everything works properly. Save that. And we're also importing the config from our WAGMI config, which we created over here. We should now have access to WAGMI React hooks throughout our entire project. Let's now create a couple of components. In source, create a new folder called components. We'll name one of them account.tsx and the other one wallet options.tsx. I'm going to copy and paste over the wallet options that I have. Now, normally you get from your connector an array of different connectors that you can connect to. In this case, I'm just going to default to the first one, which is just going to be your embedded wallet, in this case, MetaMask. And I've added just a couple of different styles to give it a nice little blue button feeling there. So I'll save that. That'll be our wallet options for our Connect Wallet feature. Let's copy over the account stuff. I'm going to remove all of the ANS items for now, just to keep this a little bit more on the simpler side. But here we are. Now we've got an address displayed, as well as a button to eventually disconnect, which just has the same exact styles as the button from earlier. So those are going to be our two new components. Let's go over to our index.js and start using them. I'm going to go ahead and remove everything inside of the main div here. And I'm just going to copy over some updated styles. With that out of the way, let's go ahead and start with our Connect Wallet feature. Let's import the two components that we just created. So that's our account and wallet options. And I'm going to create our Connect Wallet button. So let's create a function inside of home. I'm going to name it Connect Wallet. And we're going to do something where if we're connected to the user's wallet, we'll show the account. Otherwise, we'll show the wallet options. So how do we actually know if we're connected or not? We're going to import some hooks from WAGMI. We're going to import the use account hook. And use account can return to us an is connected flag. And now, if we're connected, we'll return the account. Otherwise, we'll just return the wallet options. Let's display that here. And see how that looks. Let's go ahead and run that. Head over to our terminal and type in yarn dev, and everything should be up and running at localhost 3000. Heading in here, we should see a Connect Wallet button. Yep. So let's hit Connect Wallet, connect our wallet, and once we're connected, we see our account displayed. Look good so far. One error you might run into when you refresh is this hydration error. Here's how you can solve this. We're going to go ahead and import useState from React. And we're going to create this piece of state. Has mounted or set has mounted. We're just going to wait for the actual component to mount before rendering anything inside of it. Let's create this use effect as well. So we're also going to import use effect. And I'm going to put that below, actually above the connect wallet function. And we'll say that if it hasn't mounted, we'll just return null. The reason we see this is because Next.js uses server-side rendering, and there's just a mismatch between the server-side rendered HTML and the initial rendered HTML. So this way, it will be the same no matter what. Refresh, looks like we're good. No more hydration error. All right, let's finish this up now by both reading and writing to our contract. I'm going to update the imported hooks from Acme. So there's a few more hooks. We're going to explain each of them as we go through them. And we're also going to import the ABI from our ABI/JSON. Great. With that done, let's go ahead and set up first our write and read functions. So we're going to use write contract and use read contract. Set that up over here. For our write function, we're going to get some data back, which is going to be a hash. And we're going to get the write contract function. So that comes from the use write contract hook. And from read contract, we're also going to get some data, and we'll name that current count. We'll say refetch as well, so we can refetch the value whenever we need to. And we'll use read contract, and we're going to need to pass a couple variables. First, the ABI. Next, the address, which I'll copy over in just a second. And the function name. In this case, it can be just number or the get number that we wrote. I'll just use number for now. Cool. Our last hook is going to be this use wait for transaction receipt. This is going to give us two different flags that are very helpful. Is loading for whenever a transaction is loading, and is success for whenever a transaction is successful. And that's going to use wait for transaction receipt, and that's actually going to take this hash from the use write contract. Great. So now we have these different variables that'll help us with creating our UI. Now let's create an async function. It's going to be called increment, which is going to increment our count. And this is going to use the write contract function that we got from the hook. And that gets past the ABI, the address again. We'll just copy and paste that from up here. And finally, the function name, which is going to be increment as well. And just make sure that it's passed as a string. Great, so this is our increment function. We're actually going to use one more use effect. And we're going to add another piece of state up here. This state is going to be for account. Here we'll update our count. we're going to set the count to be the current count, and we're just going to cast it as a string. And just in case, you'll recall that we have our isSuccess Boolean over here. Whenever that isSuccess runs, we just want to make sure that we refetch the value. To make sure that runs at the appropriate times, we just have to pass some dependencies into this array. And that is going to be the current count, isSuccess itself, and just the refetch function. This use effect will now run anytime current count or isSuccess is updated. Now let's update our UI. I'll add a paragraph here that shows the current count, and that's just going to be the count state variable. Next, we'll have the isLoading Boolean, which we also got from the use wait for transaction receipt. Now, whenever a transaction is loading, we'll just display a little message to the user. We'll say updating count. And lastly, if we're connected, and only if we're connected, will users actually be able to see the button to increment the count. I'm just going to copy that over. But you'll see here that we're simply on click passing the increment function that we wrote above. Let's test this out. So we see we have our current count, which is at 0. Hit increment. Pay some gas. The count is now updating. And the count is now 1. So with that, you now have the resources you need in order to start building on Morph. We've gone through building out your smart contract. We've gone through deploying and interacting with it on a front end. We have additional resources for you to go through, templates that'll go through some of the things I went through today on the Foundry side. Additionally, we also have templates for Rahat if you prefer using Rahat. And we have different front-end templates that'll show you how to use both VM, WAGMI, as well as Ethers. So whatever tools you're comfortable with in the EVM space, you'll be able to use with us right here. You can go ahead and scan this QR code to see a GitHub repo with some of those templates and resources. These have also been shared within Discord as well as on the events page for ETH Global. Additionally, if you want to get further involved inside of the Morph ecosystem, we do have a Morph Ambassador program, which is open to both developers and non-developers. So whether you're technical or not, definitely check out the Morph Ambassador program for some really cool incentives on how to get involved even deeper within the Morph community. Thank you, everyone, for checking this talk out, and I'm really excited to see what everyone starts building on Morph during this hackathon.